multiplying polynomials. Now in the notes this says it's lesson 4, but really it's going to be 2 videos. So we are doing the first 4 examples here today. And there is one thing you have to remember: exponent combination rule. If we multiply 2 copies of the same base, we can do that, make them a single copy of the base, by adding their exponents. So what's going on here? I'm going to do the first example in a very long way, comparatively, and then I'm going to erase what I write down and talk you through the faster way. So what's the long way? Just pay attention to this, just watch this, don't copy this down. This is just me showing you why this works. Really, I can break all of this up into a bunch of multiplication. 3 times r to the second times s to the third times 5 times r to the fourth times s to the fifth. And because this is all multiplication, it is commutative, meaning I can rearrange it however I please. So I can do 3 times 5 times r squared times r to the fourth times s to the third times s to the fifth. Numbers together, r's together, s's together. And now we multiply normally. 3 times 5 is 15. R squared times r to the fourth. We combine those by adding their exponents, so it's r to the sixth. S to the third times s to the fifth is s to the eighth. Do I expect you to write this multiplication all out? No. As a matter of fact, it's completely unnecessary. Instead, just do this by parts. Whole number times whole number, so 3 times 5 makes 15. R's, r to the second times r to the fourth, 2 plus 4 gives us r to the sixth. And s's, s to the third times s to the fifth, 3 plus 5 gives us s to the eighth. For the second example, 7 times negative 3 is negative 21. With our x's, we have x to the second and x to the fourth. 2 plus 4 gives us x to the sixth. For our y's, we have y times y. If you don't see an exponent on a variable, it has one, and it is the number 1. You must remember it's an invisible 1. So both of my y's have invisible 1s. 1 plus 1 means our y is going to have an exponent of 2. And z's, there is just the z to the 8th power. Done. Next example is distribution. So our first piece, negative 4 times positive 2 is negative 8. A to the second times a to the fourth is a to the sixth. And b times b to the third is b to the fourth. Second piece, negative 4 times positive 5 is negative 20. A to the second times a to the second is a to the fourth. And b times b to the third is b to the fourth. Now we do have multiple terms, so we do want to take a quick look at them and see if they agree with each other. They don't. The first one is a to the sixth, b to the fourth. The second is a to the fourth, b to the fourth. So these cannot be combined. Final example for today, we are doing triple distribution. So we're giving 4rs squared through this trinomial. First piece, 4 times, well, no variable, or sorry, not variable, no coefficient. Well, that's not 0, it's an invisible 1, so we have the 4. R times r squared is r to the third, 1 plus 2. S squared times s to the fourth is s to the sixth, 2 plus 4. For our middle term, 4 times 2 is 8. R times r is r to the second, that's 1 plus 1. And we're going to have s to the fifth, because 2 plus 3 makes 5. For our final term, 4 times negative 3 is negative 12. R times r is still r to the second. S to the second times s is s to the third. And this last term has a t that we have to bring along, but doesn't have anything else to multiply with.